Hi, this is Victor and welcome back to my math tutoring channel. In this video, we will study the limit when x goes to infinity of x plus 1 divided by x minus 2, all that to the power of x. Well, when x goes to infinity, I would have infinity divided by infinity. It's indeterminate, and even if it is infinity to the power of infinity, because that x is to the power of infinity, to the power of x, which x goes to infinity, it's undetermined. So here, if I can apply L'Hopital rule, it will make my life easier, but I don't have like this divided by another entity here to apply L'Hopital rule. I have like only a numerator. I don't have a denominator to apply the L'Hopital rule. So let's see if I can make it with like numerator and denominator. Let's take y equal to x plus 1 divided by x minus 2 to the power of x. And at the end, I will study the limit when x goes to infinity. So I know my equality is jealous. Whatever I do to the left-hand side of the equality, if I do it to the right-hand side of the equality, I maintain the integrity of my equality. So here, if I put ln of y is equal to ln of x plus 1 divided by x minus 2 and all that to the power of x. So the integrity of my equality is maintained. But here I will apply the logarithmic rule. When I have log of something to the power of something, this can come here. So ln of y is equal x ln of x plus 1 divided by x minus 2. That's it, and there is no power anymore. But this x, I can write it into a different way. Now I can say ln of y is equal to ln of x plus 1 divided by x minus 2 divided by 1 over x. Because if I want to get rid of the division, I will multiply it and I will flip 1 over x to become x divided by 1. So I come back to that equation here. So again, I'm fine. And now I want to study the limit when n goes to infinity. So let's say the limit of ln of y when x goes to infinity, which is equal to the limit. Instead of ln of y, I can write ln of x plus 1 divided by x minus 2, all that divided by 1 over x. I will write the limit here because it has to be in the middle. When x goes to infinity, yeah? So when x goes to infinity, 1 divided by infinity here, that goes to 0. And then let's see the numerator. Let's write it again. Limit when x goes to infinity of ln, and I can factor out x in the numerator. So it is x factor 1 minus 1 over x divided by, I factor out x, 1 minus 2 over x. And here I will keep the 1 over x. So now I can simplify this x with this x. And when x goes to infinity, let's take another color. That goes to 0. Because 1 divided by infinity is 0. That goes to 0. 1 divided by infinity is 0. And that goes to 0. And then I will have ln of 1 divided by 1, which is ln of 1. And ln of 1 is equal to 0. So all that is equal 0 divided by 0. So it is indeterminate. And I can apply L'Hopital rule. So all what I have to do is go back here and do the derivative of the numerator divided by the derivative of the denominator. But let's make my life easier again. So I had limit when x goes to infinity of ln x plus 1 divided by x minus 2 and divided by 1 over x. But again, if I use the logarithmic rule, ln of x plus 1 divided by x minus 2, it's equal, let's do the limit when x goes to infinity. It is equal to ln of x plus 1 minus ln of x minus 2. You studied that in previous years. This is the logarithmic rule divided by 1 over x. So now I will apply the L'Hopital rule on that numerator and on that denominator. So let's take ln of x plus 1 minus ln of x minus 2, and actually it's absolute value because ln of a negative number does not exist, and let's derive it. So the first one become 1 over x plus 1, and there is a minus here, and the second one become 1 over x minus 2. And if I want to derive 1 over x, it's equal x minus 1 prime, which is equal x minus 2 divided by, that's it, x minus 2. So it is equal, divided by minus 1, multiplied by minus 1. So this, the minus 1 will come here, become minus 1 times x, minus 1 is minus 2. Okay, so it become minus 1 over x to the power of 2 because I brought it down, so I have to change the sign of my exposure. So now if I apply L'Hopital rule, so it become limit when x goes to infinity of 1 over x plus 1 minus 1 over x minus 2 divided by minus 1 over x squared. So let's do common denominator here first, and then we're gonna see where it would take us. So on top, it become limit when x goes to infinity of x minus 2 times 1 is x minus 2 minus x plus 1 divided by x plus 1, x minus 2, and multiplied by minus x squared by 1. Because the division, I flip it and it become multiplication. So let's develop the numerator here. So it become the limit when x goes to infinity of x minus 2 minus x minus 2 minus 1 is minus 3 multiplied by minus x squared divided by x plus 1 times x minus 2. Sorry, I made a mistake here. This is minus 1 because like x minus 2, that x is here, the minus 2 is here, and minus x is here, and minus times plus is minus, and then the minus 1 is here. Let's take out those lines. Okay. So now I have plus x minus x, it factors out, and minus 2 minus 1 is minus 3 times minus x2 is plus 3x squared divided by, if I multiply this, it becomes x squared minus 2x plus x minus 2. So I have to study now the limit when x goes to infinity of 3x squared divided by x squared minus 2x plus x is minus x minus 2. I can factor out in the denominator x squared. In the denominator here, I can factor out x squared, which is equal 3x squared. I have to put the limit, sorry. It's equal to the limit when x goes to infinity of 3x squared divided by x squared 1 minus 1 over x minus 2 over x squared. So now if I want, I can simplify x2 and x2 here, and minus 1 over infinity, because x goes to infinity, is 0, and minus 2 divided by infinity is 0. So I will have 3 divided by 1, which is equal to 3. So that limit is equal to 3. So if you like my video, please subscribe to my channel. It will help me a lot, and if you put a like, I would really appreciate it. If you want me to do something else, you can mention it in the comment, and like any exercise, and I will do it for you. Thank you.